Next up, we have oral presentation 33, Fort Bend, Texas, Team 2, Mission 12 Flight Experiment.
Good afternoon. My name is Lena. Good afternoon. My name is Lena, and I'm the principal investigator for our experiment. And the co-principal investigators for our experiment are Christina, Atulia, and Michelle. The title of our experiment is The Effect of Microgravity on Apium Graveolens. So we are representing Fort Bend ISD from Texas, and our teacher facilitator is Jeanette Morales. So it is proven that in space, astronauts don't produce as much saliva as we do on Earth. So we decided to use celery, which is Apium graveolens.
The purpose of our experiment is to discover the effect of microgravity on the germination of Apium graveolens. Our hypothesis is that celery will germinate under the influence of microgravity. We hope to find that the celery will be able to germinate in order for the astronauts to be able to stimulate a healthy amount of saliva by chewing celery. This will greatly aid them due to the numerous health benefits that come from celery.
So the question that we decided to use is, what impact does microgravity have on the germination of Apium graveolens? The reason that we decided to do this is because it is proven that in space, we don't stimulate as much saliva as we do on Earth. And so our purpose is since celery contains such a vast quantity of water, that it'll stimulate, your salivary glands will stimulate more saliva when you chew celery. Saliva is important to maintain moisture levels in your mouth and to digest food. It has enzymes that digest foods, and these break down carbohydrate chains into individual glucose. Over time, the lack of glucose can lead to muscle cells atrophying, and therefore, if we provide more saliva, we can help astronauts combat muscular atrophy. Another reason why you should have a high level of saliva is because it has nutrients that help rebuild your teeth and remove excess biofilm. If you have excess biofilm, then cavities will form and your teeth will start to decay.
So the type of Fme that we will be using is Fme Type 3. The first interaction that we requested was for the astronauts to remove clamp A, which will mix the water and the soil and the seeds. After 2 weeks under the influence of microgravity, we requested for the astronauts to remove clamp B, which will add the fixative formalin to the seeds, which will stop the growth. We decided to do this so that we can get similar results for the experiment on Earth and the experiment in microgravity. We will be analyzing the results by looking at the difference between the growth of the experiment in microgravity and the one on Earth.
Once the samples return, we'll proceed to analyze the seeds as well as measure them in millimeters to observe the growth. We'll inspect the seeds grown in microgravity for strange growth patterns, such as difference in color. The analysis will help answer the question by informing us whether microgravity has an impact on germination. We will know if celery will be useful for astronauts to grow in microgravity or if another alternative is required.
As for our results, we hypothesize that celery will germinate faster in space, and if so, due to the research that was found on germinating other types of vegetation in space. Communicating the significance of celery and its benefits, we have a clear assimilation of how celery can affect astronauts. If our experiment proves successful and the celery germinates faster in space rather than on Earth, then celery germination in microgravity could become essential to astronauts.
We would like to thank Fort Bend Independent School District and the Texas Space Grant Consortium. We would also like to thank Brian Tucker and Troy Byrne for helping us bring our project to space. We would also like to give a special thank you to Ms. Morales for helping us come to Washington, D.C. and do this presentation.
Thank you.
Hello, I'm Jason. I'm a professor at Stockton University in New Jersey. I also am a product of an education from Fort Bend ISD. I went to Quail Valley Middle School for 3 years.
That's cool.
And I think I had a friend, one of my friends went to Settlers Way. Yeah, elementary school. So first, I'd like to commend you and all of the groups for really being ahead of the game. The first time I gave a presentation was not in elementary school or middle school or high school. It wasn't even in college. It was 2 years into my graduate education. I was 20. So you guys are much farther along than I am, and I'm a professional scientist. So
Thank you.
congratulations.
Thank you.
My question is, do you have any plan to share your results with your school or your community?
We might come back next year once it returns from space, and we might share our results. So,
Great. Thank you.
thank you.
Hi, I'm Cody from Berlin, New Mexico. I was just wondering why you guys chose celery, any other than any other fruit, like a pickle or...
Well, of course, in our proposal, we've done research on that, and other things like, of course, apples do also produce saliva, but they have like acids in them that soften your tooth enamel, so it's not really good for you. Same for citrus foods. Yeah.
Okay.
And when we researched celery, there weren't like negative things about them.
Okay, thank you.
Got one more question.
Hello, I'm Laura Smith from Burleson, Texas, and you did wonderful research on why saliva is important, but I was wondering, why do astronauts not produce as much saliva in space?
That could be, we actually haven't looked into that, but we could maybe do another project on that, so we'll take that into consideration.
Yeah, it's like, I'm really curious now. Thank you very much.